Hello, everyone. Welcome to our webinar. My name is Laura from Marketing KUKA team, and I am thrilled to be your host today. We have an exciting session lined up for you. But before we get started, let's go over a few housekeeping items. This webinar is being recorded, and we will share the recording with you afterward. If you have any questions during the session, please feel free to write them in the chat at any time. We will address them as we go along. And now, the introduction of our speaker. It is my pleasure to introduce Charles Adams. Charles is a business development manager of KUKA's industry management team, specializing in auto suppliers and metal. Over his 8 years with KUKA, he has concentrated on joining technologies, particularly arc welding processes. Charles has been actively involved in various aspects, including pre- and post-sale support, trade shows, on-site assistance, training on KUKA technology packages, and supporting the Joining Technology Center. We're honored to have him with us today, and we are handing over the microphone and the screen to you, Charles.
All right, that was quite the intro. Thanks, Laura. We'll get started here today. Get right into it. The big overview is what KUKA does in welding. So there'll be some pretty high-level aspects being more or less what we've done at different projects around the world, whether it's basic arc welding all the way to very specialized laser hybrid systems and a little bit of everything in between. So if you have questions, maybe on a particular process, I would write them in the chat, and that way we can cover them and answer them while it's still relevant and not at the end. So brief introduction. My background's welding engineer out of Fair State. Been with KUKA, like Laura said, a little more than 8 years now. Certified weld inspector. I've been in welding since the beginning of my professional career, and here we are. So, some of you may have seen this before. I see there's some familiar faces in the crowd. KUKA really started its life in welding. We started as acetylene gas plant, made our way into oxyacetylene, really into spot welding is where we made our foothold. Eventually into some friction welding, eventually into the first electric motor driven robot, laser welding processes, cobots, and we're ever evolving. So we're always kind of on the forefront, working with what we would call tech partners, the leading innovation companies out there. We're working with them in our labs all around the world. So today we're primarily focused on North America for our group, and we cover everything what I would consider joining or cutting. So our group would be US, Canada, and Mexico. In our tech centers, we do arc spot laser, and of course we can do demonstrations and feasibility studies, process development with any equipment that you see fit. So if there's maybe a process or a project that you're not confident in, that's really what our tech centers are for. And we'll get into this in a little bit, but ultimately at the end I'll give you my contact info. If you have questions, feel free to reach out to me or your local salesperson. So again, some of you may know this. Really, the portfolio at KUKA is all driven around processes. So even though it is what I would consider a naked robot, when we get it, we like to be able to support you on whatever that process is. So whether it's sub-arc, laser, arc welding, our entire portfolio is based around making it ideal for your application. So whether it's large gantries, using linear tracks or positioners to put your weld in the optimum position, that's kind of what our whole platform is based around. So first things first, we'll start with arc welding because that's probably what most of you know. Arc welding, of course, is what I would consider for the most part, a cheaper process compared to some of the ones we're going to talk about. It works for a lot of applications, not everyone. It's something that we've been doing for a long time. So today we're going to go over just very high level overview of what KUKA does, some of our tech packages, and then we'll get into some of the more interesting processes. So here in the US, we're primarily focused on a handful of welding power supplies, but obviously KUKA is a global company. So here are just some of the companies that we work with. It doesn't matter what the communication protocol is. We work with everybody, whether it's Miller with Ethernet IP, Fronius with EtherCAT, Lincoln Electric with their ArcLink XT, or anything in between. We have pre-configured systems for all of them to help make it easier for your integration or once it gets on site to your customer. In this video here, you can see a nice application of what we call RoboTeam. So 2 robots working in one system to manipulate a part. One is acting as the positioner and one is acting as just the torch. So in our testing facilities, we have here in the US, we have Fronius, Miller, Lincoln, SKS, and ESAB. So if you're ever interested in learning more about those, that's what our tech center is for. And then obviously at some of these other companies, they have our equipment in their lab as well. So when we talk about ArcTech, which is our arc welding software, it all starts with ArcTech Basic. This gives you a lot of functionality, a lot of configurations on what you can do inside the arc welding software. If you do need to dive a little deeper, let's say you need to set up more advanced air routines. How do you handle if there's a fault in the middle of your weld, setting up escape routes, things like that? That's when we start to suggest things like ArcTech Advance. Of course, there's a lot more involved with just ArcTech Advance, and if anybody has questions, feel free to reach out afterwards, and I can dive as deep as you want on any of these topics. The next one is a little newer for KUKA. It's ArcTech Multilayer. So the idea is that you can use multi-layer in conjunction with TouchSense, ThruArc seam tracking, seam finding, and you're just finding that base layer, that base path, and then doing shifts based on your weld parameters. You can do up to 99 paths. Obviously, that would be a pretty substantial weld, but yeah, there's people out there doing it, and it's quite impressive. Seam tech finding, that is done with a laser sensor, and what it is, it would be to find the part or to track a seam, drop a camera, maybe because the weld path is not consistent and you need more room and the camera doesn't allow it. This is when you would use seam tech finding. And of course, TouchSense is a basic down and dirty, cheap way to find the part using the welding wire. Takes a little bit of time, but it's tried and true. Okay, so ArcSense would be our version of what everybody else calls through the arc seam tracking. We've done a lot of testing, a lot of rework on this, and it's quite a stable product. We use this in a lot of very difficult, non-repeatable applications using, again, all the major power supplies. Assuming they give good feedback to us, we can use their signal and track that seam. Seam tracking, as this shows, would be live during the weld or gluing process or whatever that application is with a laser tracker. ArcTech Adaptive is a newer tech package for us. We are looking for some more people to put this into real applications. We have some very high-level applications, both in Tier 1 and in rail cars using this adaptive, but ultimately it's to call different weld procedures based on joint type. So if your joint changes a lot during the seam, you can call different weld parameters, maybe weave parameters on demand. Track TCP is our basic tool center point sensor. It works very well. We use it a lot, primarily in arc welding, in spot welding, glue dispensing, and I've even seen it in some milling applications, depending on the design of the tool. So to make things a little easier, we have what we call ready to arc. We kind of look at the standard packages. Now we can ready to arc anybody's system really. This is when we mount the equipment, strike an arc with it, and ship it to your integrator or to you. But if you want us to buy all the equipment, we typically like to go with something that's a little more standard. Like here on the screen, I have the new Lincoln package from them with full dress kits and everything. We work with really Miller, Lincoln, SKS, and Fronius to build these standard packages, typically for steel, aluminum, and water-cooled applications. So next, we'll see some TIG welding, a little less common for robotics, but definitely still quite an interesting process when you get into it. Doing things like arc sense on our side to do varying height, with current voltage feedback from the power supply. Typically, I see only Fronius in this application. Their magic wave system is very nice. Usually in robotic applications, high frequency is the problem, whether it's TIG or plasma cutting. But obviously, we have these working in a lot of areas all around the world. Typically in aerospace and medical would be where I would see TIG welding applications. Of course, spot welding. I'm sure quite a few of you on this call have a lot of spot welding experience. These would be some of our major companies that we supply spot welding systems to, whether it's Tesla, Daimler, Magna, or other. Spot welding is something that we do differently. And again, this is coming from a welding person. There are some things that we do that I'll get into. So we really have 4 different packages for spot welding. We have servo gun basic, and that is for anything position based. Still a lot of functionality in this. Servo gun advanced, maybe for your harder materials, maybe some aluminums. Maybe you need to do dual force. A lot more functionality here, but there is more complexity in initial setup. RoboSpin, this is one thing that we do really well with aluminum spot welding. And again, we'll get into this in a minute. And equalizing tech, where we can just deal with, maybe a little more cost-effective guns. So Usually the best way I can explain spot welding, really there's 3 parameters. 2 of them are controlled by the weld timer. Only one of them is controlled by the robot, being in this case force. And this is something that we control very accurately, in which case it makes weld quality improve and ultimately KUKA a better choice for spot welding. So with the way we actually calibrate here, we have a sensor rather than doing like a handheld tool and manually typing in the numbers. We have a wizard that you plug and play. You plug it in, do the initial setup. It doesn't matter what the gun looks like. It goes through this calibration routine until it finds, at a set position, it's calling a particular force. And this makes it very easy for people to, once it's calibrated, call the correct force on the teach pendant and verify that they're getting exactly what they're calling. This tool is part of what I think makes us stand out a lot better. So, and then if you are doing more aluminum applications or need a little more accuracy, you just need a little more than Servogun Basic has. We have Servogun Advanced, and this has a closed loop force sensor, typically built into the motor. If you're buying it from one of the major manufacturers like Milco or Toolmatic or somebody, and then they work with us. You just spec out that, hey, it's going to go on a KUKA, and this allows us to get even more quality and control on that weld. And then again, what I believe sets us apart is RoboSpin. So of course, you could use it on every single weld, steel or aluminum, but really where you see the difference would be aluminum. So what it does is it actually rotates the electrodes during the weld or after the weld, depending on how your weld engineer sets it up. And what that does is it actually breaks the oxide layer. So it sounds kind of silly, but what it does is it allows you to go more spots between tip dressing. So if you're not going in tip dressing as often, that means that you can not replace your tips as often and ultimately make more parts at the end of the year. Again, as a welding person, this is really the big feature right here for aluminum. Any questions at this point?
There is none in the chat right now.
Okay, that means I'm answering everybody's questions. Okay, so next we'll get into laser welding, and again, as I mentioned at the beginning, this is all pretty high level overviews. If you want to go deeper, either stop me or let's set up something afterwards and we can dig in. So KUKA is typically seen in laser applications. When I go to large manufacturers, I almost always see, I would say 99 out of 100 times, it's KUKAs in the laser applications, whether it's cutting, welding, brazing, or other. And this is for a few reasons. This is accuracy, repeatability, and in the case of additive, it would be CAD to path. So, dealing with a CAM software to go into a real life application. I see KUKA is really leads this field. So let me try to play this video again. So here on the bottom right, you can see a laser application that we did with a Meltio system. So Meltio is not the highest power, but it's still the same application, whether it's low power. We do this with arc welding all the time as well. But again, it's all back to the CAD to path and being able to make parts, assuming your weld process is dialed in. to the same specification that your CAD is calling out. So laser cutting, of course, it's a big process for us. We have some model robots that we do call out before others for laser cutting and welding applications. Typically, we like to add a package we call absolute accuracy. And what this does is it actually build custom machine data for that particular robot. It just allows you to get tighter circles, straighter lines, whatever your application calls for, it's going to hit that mark. And again, if you want to see any real applications or tests or anything, we have a laser system going into our facility right now, and I think pretty much all the laser companies here in Detroit, all the major ones have KUKAs in their lab that we can run tests with them. So we actually have a software specifically for laser welding and cutting. It's called LaserTech, and I'm not going to dive deep into this, but ultimately the idea is, hey, we have pre-configured standards with all the major players, Trump, IPG, Laserline, Fraunhofer, some of the other ones. But the idea is that we know what their weld and cutting timings look like, so you can build this procedure very easily. And again, it's just made to make your guys' job easier once it lands at your facility. And with that, we also have some predefined shapes, predefined buttons as far as, if you want laser on, laser off, things like that. And if you as the integrator wants to change things, it's open. It's fully configurable however you want it to look like. You can make it function in the way that you need. So from here, of course, laser hybrid would be the next kind of rendition of laser and arc. This would mean that there's a wire process involved. Typically there would be hot wire or cold wire. Hot wire being that the welding wire is preheated through a welding power supply. Right now the big buzzword in automation would be PPL, precision power laser from Lincoln. We have this process running in our Germany lab right now. Ultimately, how we handle it is we do a combination of ArcTech Basic and LaserTech. And all we're doing is sending those signals at the right time to make both parties' functions happen. There we go. So of course, again, you can configure it however you want, but we give it as a generic, generally can function enough to make some basic welds or basic cuts, and then you can make it however you need. So the big topic lately would be friction stir welding. Of course, KUKA is the leader in this. We have a lot of these systems out in the field globally. This process has been around longer than I have, but ultimately the best way I can explain it is milling gone wrong. So when you think about a mill going into a part, typically it's a bad time. We're intentionally doing that while being carried with the robot. So here you can see, section 1, we're plunging that bit into the material. We're dwelling, then we're moving, and then we extract. What that does is it makes a very nice weld. Here we'll see a little video of this. I'm sure some of you have probably seen this. If you were at our open house the other week, we had this running live. The big application for this right now would be battery trays. You know, obviously it's not the only application, but big aluminum structures, we can plastically melt those materials together. The heat affected zone is generally minimal compared to even laser. It's about the speed of an arc weld. That's the best way I can explain it. But the real benefit is doing this, you can go out of position, you know, versus a gantry style system, and you can weld a lot of different materials together. So here on the right, you can see aluminum sheet, copper sheet. You know, we've done, you know, everything on the left would be confirmed. We've done them, you know, different like 2000 series with a 6000 series, aluminums, or, you know, copper to, you know, steels, things like that. Has a lot of use cases, but you got to make sure it makes sense for your application. I would say this is one people probably know generally the least about, but I don't see any questions, so we're okay. Of course, we have to explain, you know, we have 200 of these out there in the wild. Again, primarily in the automotive sector, being batteries, being the main driver on that. The next thing that most people don't know that KUKA is involved with would be rotary friction. Instead of a mill gone wrong, think of a lathe gone wrong in this application, where we're actually spinning one side of the part and we force it into the stationary side of the part and melt these two materials together. So phase one here, you know, the pieces clamped into both sides. To me, the most common application that I've seen would be drive shafts. So if you think of a drive shaft, you have the centerpiece and the two yokes. The centerpiece would be clamped. The two yokes on either side are spun at a pretty high RPM, and then they're forced into the centerpiece where they get this curl here. And typically after that's done, it would be removed, so that way it can not be a stress riser later in the world. So here you can see it being spun up to speed, pushed together, start to roll. You know, it makes a nice curl, and then typically, not always, depending on the customer, but it would be you know, machined off. Again, typically we see this in the automotive sector, but you might see this in oil and gas, depending on what the materials look like, depending on how repeatable or common that part is. And here's just a good list of the different materials we're combining, right? You know, coppers to, you know, titaniums and things like that. So it has a lot of use cases, as you can see on the right side. You know, turbo rotors, drive shafts again, lugs. Yep. And this, we have a lot more systems out there in the world. KUKA actually owns a different company over in the UK called Thomson. You know, between the two of us, we I would say are the primary brands. And we deliver these all over the world to varying you know, applications. So you know, those are the main welding processes that I was talking about today. Of course, with welding, you have typically grinding. So this is an application that we've done a lot of, you know, between the force feedback on our system or between other manufacturer systems giving us feedback, we can make the robots very compliant. And They can teach, mins and maxes quite easily, and make it quite a repeatable grind. Of course, we've done things with 3M and PushCorp and all the major players. This is a good overview video. Yeah, pretty nice. Yeah. Some other ones that you wouldn't see too often, it's very specific application where you'd be doing submerged arc welding, typically heavy deposition. Right now we're doing a system with an integrator doing electroslag additive. Ultimately, the big point of this is that this whole webinar is that we've been involved with a lot of different welding processes. The welding group at KUKA has been around quite a long time. Like I said, we've been doing this 127 years. I've been here 10. Most of the welding group in Germany has been here upwards of 15 or 20 years. And of course, we're bringing in new people and new processes and new expertise every day. So, we've just been around the block. If you have a question on something that you haven't seen done robotically, we can probably ask that question internally and find either a video or a customer who's done it, and maybe give you a little insight. So, like I said earlier, with welding typically comes positioners. We make a pretty wide range of positioners from 1, 2, 3, 5 axes. 250 kilograms up to 6,000 kilograms, depending on the shape of these. And the nice thing is that they use common parts between the robots. So the same mastering technique that we use on robots is the same that we do for positioners and linear tracks. So setting up coordinated motion and that CAD to path that we talked about earlier, it makes it seamless, right? If for some reason we don't have a positioner that meets your needs, what we do offer is an MGU, a motor gear unit, and you can build whatever you need. I've seen up to, I think, 14 axes on one system doing robo team, so they can get pretty extravagant pretty quickly. But again, we've done a lot of these. So if you have questions, let us know. And here's a high-level overview of some of the standard positioners that we make. Of course, they're modular. So the idea is, let's say you want a headstock, tailstock, but you want it a larger tool radius. We use the KP1 and we put a riser underneath of it. It allows us to have faster delivery times, less spare parts, and just build more standard units. The next transition would be, of course, linear tracks. We're a major supplier for linear tracks globally. We offer these in, I would say, 1 million different configurations, multiple robots, multiple carriages. We have specific software for lubrication systems so that it knows where in the track it rides the most often, so it only lubricates as needed in particular areas, so you don't have a huge mess on the floor or excessive wear in one spot. We control all of that. You can get your dress kits specific to however you want, or if you want it to be up to you and the integrator, we can leave the track fairly empty outside the robot. I don't remember the exact segments, but the nice thing is if you decide down the road that you want to add sections to this, it's the same process. You take out the end stop, you add another link, and you continue on. You know, I've seen these in applications doing rail cars, probably 60 meters long. You know, multiple robots, multiple carriages carrying spools of wire and the welders and all of that. So with all of that, of course, the next step would be making it all work. Again, you know, our CAD path, I would say, is top tier. KUKA Sim allows you to, you know, build your whole system before you ever get it. Specifically for arc welding, but again, if you have a different process, you know, we can just add some different plugins and make it function for you. And generally, that's it. I know that was a lot to take in. It was quick, very high level, but the idea is that, you know, it gets you thinking about applications we've done, applications we could do, and really that we're here to, you know, help you guys feel confident and learn with you. And if you have an application that you said, hey, there's no way, you know, that's what our tech center is for. So I see there's no questions, but you know, I did a lot of talking very quickly. So if you have a question, let me know or type it in the chat. And if not, there's my contact info. Feel free to reach out to me about anything welding in general.
Industrial intelligence.